To start off Chapter 8, we're going to look at inverse variations. First, let's recap what a direct variation is. We learned about these back in Chapter 3 or so, and they always come in the format of y equals k times x. And k is a constant value. If we want to find what k is, we'd have to divide both sides by x. That means we find k by doing y divided by x. Since it's a direct variation, both x and y are going to either increase or they're going to decrease. They're always going to be going in the same direction. The graph of a direct variation is going to be a straight line that goes directly through our origin. On the other hand, with an inverse variation, it's always in the format y equals k divided by x. Again, k is going to be a constant. If we want to find k, we'd have to multiply both sides by x. That means we find k by doing x times y. And with inverse variations, one quantity is going to increase while the other one decreases, or vice versa. They're always going opposite directions. What this looks like is we get kind of a curved graph in the first quadrant, and we're going to get another curved graph in the third quadrant, with an asymptote going through the y-axis and an asymptote going across the x-axis. There are a couple different ways we can tell if we have an inverse versus a direct variation. The first way is with a table. We can look and see, are our x and y values going the same direction or opposite directions? If it's a direct variation, then that means the values are going the same direction. If it's an inverse, then they're going to be going opposite directions. In the first example, our x's start with 2, ends with 15. So x's are increasing. Y starts with 15 and ends with 2. They are decreasing. This tells us that for sure we are going to have an inverse here. However, we need to find what the constant is if we're going to write the function model or the function rule. If we go back up to our top summary we just did, we said that we find the k value for inverses by doing the x value times the y value. So if we multiply x and y together in each of these cases, we're going to get 30 in all four. This is telling us what our k value is. If we plug it now into the equation for an inverse variation, we're going to get y is equal to 30 over x. In our second example, again, let's check. Our x's start at 0.2, end at 1.5, so they are increasing. Y starts at 8, ends at 60, so they're also increasing. Since they're both going the same direction, this tells us that we do have a direct variation. And with direct variations, the constant is always equal to y divided by x. And it's super important that we always do y divided by x, not x divided by y. So we'll have 8 divided by 0.2. That gives us 40. 20 by 0.5, also 40. 40 divided by 1, 40. And 60 divided by 1.5 is also 40. And again, this is telling us what that k value is. Now that we know k, we can plug it back into the equation for a direct variation, which is y is equal to k, which in this case is 40, times x. So in both problems, we were able to tell if it was inverse or direct, and we were able to write what the function model or the function rule is for the given table. Pause the video and answer this question for yourself. How can you tell if a set of values is an inverse variation? What are things that you notice from this example? Next, we're going to take a look at how we can work with a known inverse variation. Suppose that x and y vary inversely, and x equals 4 and y equals 12. First, we're going to write what function models the inverse variation. Going back to what we know about the summary of an inverse variation, we always find k by doing x times y. And since we know both x and y, we can find k. So k is going to be equal to x times y, which in this case is 4 times 12, and that's going to give us 48. Once we know k, we just plug it back into the equation of an inverse, so y is going to equal 48 divided by x. Here is our function model. Once we have the function model, we can figure out what this graph looks like. Here are some x values we're going to plug in. I know on your notes it says negative 36 and positive 36. Go ahead and change it to negative 48 and positive 48 instead. If we plug in negative 48 in for x, we're going to end up with a negative 1. If we plugged in negative 12, we get negative 4. Plug in negative 8, we'll get negative 6. Negative 4, we'll get negative 12. And if we plug in 0, we're going to notice that we get an error. That's because we can never have 0 in the denominator. So we're actually going to end up being undefined here. This is what's going to lead to us having an asymptote on both the x-axis, and we're also going to have an asymptote on the y-axis for that reason. If we plug in a positive 4, we get out positive 12. 8, we get out 6. 12, we get out 4. And 48, we get out 1. Again, we're just taking each of these x values and we're plugging them into x into our equation. And we picked x values that fit in nice whole numbers. Let's go ahead and put these on our graph the best that we can. Here are the points that we have so far. We have enough points here to kind of give us this basic shape. We're going to be curving down here in the first quadrant, and we're going to start approaching the x-axis, but we're not ever going to cross it. We're going to do the same thing in the third quadrant. We're going to come across and connect these points into a nice curve, and then we're going to get really close to the y-axis, but again, we're not going to cross it. And here's our graph of the equation y equals 48 over x. Lastly, by knowing the function model, we can figure out different unknown values. Let's say we want to find what is y when x equals 8. Well, we put that into our equation. Y is equal to 48 divided by x. We're going to put in our x value, which is 8. Go ahead and divide, and we're going to find that our answer is 6. So to recap, first we need to always find what our k value is. Once we know k, we can write our equation. Once we have the equation, we can make a table of values. When you're making a table of values, you do not have to put this many points on your homework. You could maybe plug in 2 or 3 points and that would be sufficient. Just make sure you're picking x values that fit into the equation nicely. Lastly, we could then plug in some known value into our equation to find out a solution. Those are the different things we can do so far with an inverse variation.